Hello, in this video I'm going to go through part H on question 1 of Math 2014, and here they've defined a function f where f1 is equal to 0, and for all n greater than or equal to 2 we have that fn is fn minus 1 plus 2 if 2 divides n but 3 doesn't. If 3 divides n but 2 doesn't, then we have plus 3 on the end, and we have plus 4 if they both divide n, and fn is just fn minus 1 if neither 2 nor 3 divides n, and we're asked to work out the value of f 6000. Well, I suppose you could think that, okay, I'll just use the recursive formula and go f of 6000 is equal to f of 5999 plus, well, 2 and 3 both divide 6000, so I'm going to have plus 4. But then, if you want to get down to something that you know the value of, we're going to have to reduce this all the way down to f of 1, and well, to do that we're going to have to do this like 6,000 times, so that's going to take a very long time, much more time than we have in the exam. So what is a quicker way to do this? Well, if you look at how the function is defined, each time I'm just going to reduce the argument of f from n to n minus 1, and then I will add on a different amount, 2, 3, 4 or nothing, depending on whether n is divisible by 2 or 3, or neither or both. So really we just need to work out what we're going to be adding on each time. And a much quicker way than going through from 6,000 all the way to 1 would just be to work out how many times we're going to have add 2, i.e. how many n's are going to be divisible by 2 but not 3, and how many times we're going to have to add on 3, so how many numbers are divisible by 3 but not 2, and how many times we're going to have to add 4 and nothing. So well, the number that are divisible by both 2 and 3 are just those numbers that are divisible by 6. And between 1 and 6,000, we're going to have 6,000 over 6, which is 1,000 of those. And we're going to have 6,000 divided by 2 equals 3,000 numbers which are divisible by 2. And so if we wanted the ones that were divisible by 2 but not by 3, then we'd have to take off this 1,000. So that will leave us with 2,000 numbers. And for those numbers divisible by 3, we're going to have 6,000 divided by 3 equals to 2,000. And if we want the ones that are divisible by 3 but not by 2, then we're going to have to take this 1,000 off again. So that's going to leave us with a total of 1,000. And so we can see that we're going to need to use this first rule, divisible by 2 but not 3, so we're going to do that 2,000 times, and we have 1,000 n's between 1 and 6,000 which are divisible by 3 but not 2, so we're going to need this second rule 1,000 times, so we'll be adding on 3 1,000 times, and then we're going to be adding on 4 1,000 times 2, because I have 1,000 numbers which are divisible by both 2 and 3. And for this last one, we don't need to add anything, so we don't really need to worry about too much about that. So, all in all, we're going to have this much, because, well, f1 is 0, so eventually when we get down to f1, we're going to have added on this much altogether. And this is equal to 11,000. Oh, and I've just seen that I've written this wrong, this should have another 0. So our answer is C.